day 2 of the second annual Cape Coastal Conference. We've had a split in terms of the days on the themes that we're talking about. Yesterday we spent quite a bit of time talking about a lot of topics related to improving water quality. And today we're going to be turning our attention to be looking at the whole issue of building our resilience to storms, sea level rise, and climate change. Of course, this is a very weighty topic, has a lot of different elements to it. And I know that we won't be able to get through and cover all the different dimensions of this big theme, but we do want to bring it home for the Cape Cod region and hear about some science, some projects that are underway, and have a chance to have some dialogue about where we can go in terms of next steps. I know some of you were not here today, so I am going to just take the time to recognize again our sponsors and contributors for planning this event, because I do think it's important to highlight who those individuals are. So if you heard this yesterday, just bear with me as I go through those preliminary comments again. I just want to highlight and thank the organizations that have been working with the LaPorte Bay National Estuarine Research Reserve to plan and implement this event. So I'm going to take the time to call each organization individually so you can know who they are. We have our parent organization for the LaPorte Bay Reserve, the Massachusetts Department of Conservation and Recreation, the National Oceanic and Atmospheric Administration, and between these two agencies we've got the bulk of our funding for this event, and all our other sponsors have contributed money and time to helping us plan it. We'd like to thank our hosts, the Cape Cod Community College, the Woods Hole Sea Grant Program, the Provincetown Center for Coastal Studies, Cape Cod Commission, the Free Bays Preservation, the LaPorte Bay Reserve Foundation, which is a French group of the reserve, the Association to Preserve Cape Cod, and the Mass Department of Environmental Protection, the Massachusetts Bays Program, the Association of Planners, and the Massachusetts chapter of that organization, and the Massachusetts Coastal Zone Management Program. So as you can see, I have quite an array of partners spanning state, regional, and local entities. So just thank everybody again for all your time and effort. And also we had exhibitors, some were here yesterday, some might still be here. And these are a group of individuals who all have also contributed to having displays and for you to kind of view. And then our planning team members, I do want to take the time to call out them individually. Some of them I know are coming in a little bit later today because of other work duties that are going on. But if they're here, I'd ask them to stand so you can recognize them. Pat Hughes, Brian Dudley, Judith McDowell, Joanne Muramoto, Erin Perry, Lindsay Council, Steve McKenna, Judith Underwood, Brian Curry, and then all the reserve staff that we've been interacting with you in some way, shape, or form. So thank you to all those individuals who have worked hard on this event. And the conference objectives, I just think it's important to frame up what it is that we're trying to do today and what we're hoping to accomplish out of this event. So I'm just going to walk through about 4 or 5 key objectives and we're framing up our time today. The first one is that we've launched this coastal conference. Many workshops and conferences have happened in this region and otherwise, but we want to just have this be an annual event that is dedicated towards providing the best available science-based information to local decision makers that they can apply in helping their communities become more resilient to coastal hazards. And that's part of the theme for today, and so we're saying that whole dynamic of getting information into the hands of decision makers who can use it and apply it in their work is what we're about. So we're hoping that after today's endeavors, you will leave feeling more informed about the topics that we're talking about. You will feel that you've gotten some information that you can deliberate on, that you can take back to your respective organizations, to your boards, to your committees, and incorporate it in what we're talking about. And if that happens, then we've been successful in achieving that objective. Secondly, we just want to create a forum to encourage more dialogue and discussion on these topics. They're huge, they're complex, there are many dimensions to them, and having a chance to just take stock of where we are and having a chance to come together to talk about them and learn from each other is really, really important to do. Thirdly, we want to just increase knowledge and understanding of the risks that this region faces from storm, sea level rise, and climate change, and actions that are currently being taken, and actions that could and need to be taken to address them. So we're going to have a chance to talk about that this afternoon. And lastly, I think it's also important at these events that not just information sharing be a part of it, but that we have a chance to feel inspired, because to take on these new challenges as we go forward, we're hoping that you will, as part of the learning, as part of the networking, feel recharged and inspired to continue with the development and implementation of solutions to increase our region's resilience to coastal hazards. And just quick, that's all the preliminary things I'd like to say. Now we're going to turn to our theme of today, which is all about resilience. And we have speakers today that are going to unpack that term in different ways and express and talk about what that could mean and what it should mean in terms of our decision-making, planning, conceptualizing how we move forward in terms of building resilience. But I just wanted to pull out a few bullets. The term resilience is really talking about how we ensure that our communities are positioned in such a way that they can bounce back after absorbing some kind of impact. And if you think about it, it's really getting at the fact that we're exposed to hazards, we're vulnerable to hazards, but what we want to do is make sure that within our planning, within which how we're doing our work, how we're continuing building our economy, how we're working and together, we're trying to make sure that our region can have some level of toughness, resistance, flexibility, hardiness to absorb impacts, and with some degree of flexibility. So that whole thrust behind resilience is being able to deal with impact in a way so that you're not completely overwhelmed, you can be able to bounce back. And so this is going to be a thread that will flow through all of our deliberations and talks today. And resilience has a couple of different dimensions to it. I'm not going to spend time going on each one because our speakers, again, they're going to do a lot more on these topics, but just to frame up that we're talking about, there's an element where mitigation, doing something before to avoid impact or reduce the impact that you're likely to face, that you need to prepare and adapt and be able to respond effectively when you are impacted by hazards and be able to recover in a way that allows your community to be sustainable and to not be overwhelmed. And so these are some of the things that we're going to be unpacking and talking about today. And with that, I want to just say that we have two keynote presenters that will be starting our discussions today. The first one is going to set the stage for us, thinking about climate change impacts, what it is that we're facing, and use that as a backdrop of how we move forward in the discussion that will flow from that. And that person is Dr. Scott Doney, who is at the Woods Hole Oceanographic Institution. But Scott is a senior scientist at the Department of Marine Chemistry and Geochemistry, and he's presently the director of the Ocean and Climate Change Institute at SUI. And he's graduated with a BA in chemistry from the University of California, San Diego, and he has a PhD in chemical oceanography. He also has been a convening lead author for the Oceans and Marine Resources chapter of the 2004 U.S. National Climate Assessment, which was recently released. He was awarded the James D. McElwain Medal from the American Geophysical Union in 2000. He was also an Aldo Leopold Leadership Fellow in 2004, a AAAS Fellow in 2010, and the Huntsman Award, and he received the Huntsman Award for Excellence in Marine Science in 2013. So with that, Scott, thank you for taking the time to give us this talk today.
So good morning. As Tana mentioned, I was a member of the writing team for the National Climate Assessment, and I'll talk about that a little bit at the end. But our goal was to take what's been talked about as a global problem of climate change and try to look at what the impacts are on a regional and local scale for different parts of the United States, but also for different sectors of our economy and for communities, and really bring this home in a way that would be useful for decision makers, whether they're individuals, communities, states, and municipalities. So I'm starting here with, on the left, a panel showing the global temperature rise over the last century and a half. And what you see is the latter half of the 20th century was considerably warmer than the historical period. And we now have data going back over the last several thousand years demonstrating that the current climate that we're experiencing is much warmer than the Earth has seen for at least the last 1,000 to 2,000 years. That rapid climate rise is associated with an increase in the amount of carbon dioxide in the atmosphere. This is primarily because of fossil fuel burning and the release of carbon from those fuels that stays in the atmosphere, and also because of agricultural and land practice changes, particularly during the 1800s. The other thing you see if you look at the panel on the left is that although carbon dioxide has been going up monotonically with time, it's continuously going up, the global climate change and the global patterns of temperature are not monotonic. There's lots of variability. And so, as with weather, what we have to do is we have to look at the natural cycles of the Earth's weather and climate system along with this human perturbation. And so that makes it very tricky to make predictions for what the weather is going to look like next year, but does give us some confidence that the general trends that we're seeing we can predict over decades to come. So I talked about temperature. There are lots of other indicators of climate change, some of which are very relevant to our local system here. So if you start off, if I can find the pointer, if you start off here, so for example, temperature over land is going up. We're seeing reductions in the size of glaciers and ice sheets. That turns out to be important because the water that's melting off those glaciers ends up in the ocean and is contributing to sea level rise. Ocean surface temperatures are going up, but we're also seeing an increase in the heat content over much of the water column. So it's not just the thin surface layer, but it's large volumes of the ocean that are heating up. And as ocean water warms and expands, that too is leading to sea level rise. We're seeing reductions in sea ice, particularly in the Arctic. Perhaps not that relevant for our local system here, but globally this is a very large issue because it's opening up new paths for trade and transportation, oil and gas, and resource exploration, and also issues for national and military security in that region. Finally, a warmer ocean evaporates more water. So there's more water vapor in the atmosphere. This will drive more rainfall. It can drive stronger storms. And I'll touch on that a little bit later about what those impacts are on the water cycle. So not just the temperature patterns, but also the water cycle are seeing large changes driven by climate change. So what do the patterns look like? I showed the global trends. What do the patterns look like on a national level? So this is a reconstruction, both in time in the lower left panel, and the spatial patterns of temperature change over the last several decades. And what you see is substantial warming, particularly in the Northeast and the New England region, that is comparable to or larger than the global average. In addition to sort of gradual warming, we're also seeing increase in many things associated with warmer temperatures. So we're seeing increase, for example, in the intensity and the duration of heat waves, and also, as I'll talk about later, drought. So it's not just that the mean temperature is going up, we're seeing an increase in the extreme temperature events. So if you're worried about heat waves that break some threshold, say 90 degrees Fahrenheit or 100 degrees Fahrenheit, you're seeing a dramatic increase in those intensities over time as the average temperature of these regions increases. We're also seeing increases in sea surface temperature and in our coastal waters. This is a reconstruction shown here where you see substantial warming. In the 1940s and 1950s, there was a bout of warming, and then there's been substantial warming recently, particularly 2012 was a record-breaking year. It's the warmest period that has been observed or reconstructed for the Northeast Shelf. And if you look at the patterns, what you see is substantial warming all along from basically Cape Hatteras up through the Gulf of Maine and up off the Newfoundland banks. Now that warming will likely continue into the future. and is associated not just with this global warming, but also changes in atmospheric patterns and circulation patterns. So what might the future look like? Well, a lot of that depends on what, as I mentioned earlier, a lot of the warming is associated with carbon dioxide that we're emitting to the atmosphere from fossil fuel burning. So our future is going to depend a lot on how much carbon dioxide we continue to emit. So probably the biggest uncertainty for what the climate's going to look like in 50 years or 100 years is what human decisions are about emissions of carbon dioxide, choices in our energy cycle, and what we do in terms of the waste that we release to the atmosphere. So this is just showing for a low emissions case and a high emissions case. These are increases in annual mean temperature in Fahrenheit. And you're seeing for a high emissions case, increases in annual mean temperature on the order of 8 to 10 degrees Fahrenheit. So far, the global temperature increase has been about 1.5 degrees Fahrenheit, and we're already seeing impacts. This would suggest that continuing along this pathway, the impacts we're already seeing will be greatly exacerbated. So what might some of those impacts be? What are some of the impacts we're already seeing that are relevant for coastal communities in the New England region? One of them associated with warming is changes in the distribution of where species live in the ocean. As you warm the ocean, there's growing evidence that fish species tend to, they have a thermal habitat. They have a temperature regime that they like to live in. And so as the water's warm, they will tend to move towards the poles or move into deeper water to stay in that same temperature habitat. And so this is shown here for one particular species where in the 1960s, when it was relatively cool, this particular fish was found primarily south of New England, but more recently it's migrated and moved up into the Gulf of Maine. And so this is just showing for this particular fish that not only is the population moving northward in time, but where it's being caught is moving north as well. So the landings track with a delay. And that has implications for coastal communities. If you are fishing a particular fish species that's moving northward, if you're up in the Gulf of Maine, this has been good for you if you want to fish this particular fish species. But if you're down here in southern New England, that population has declined dramatically. And so we may not see collapses in fisheries, but what we're seeing is a migration of fisheries out of the traditional regions where they were living into new waters, which provides a lot of challenges for many fishing communities and a lot of fishermen. One of the other things that happens with warming is that we also change population dynamics. We change growth rates, reproduction rates, the ability of fish species to capture prey, the density of the prey that they depend on, for example, the plankton that they might feed on at different times of year. And we're trying to develop the scientific understanding and models that would allow us to make predictions of not only those shifts in where the species are living, but how big the populations are going to be. And these are some preliminary results that were captured in the National Climate Assessment and some of the technical documents for example, cod. Cod's a cold water fish, at least in the New England region. As you warm water up, you expect the cod population to continue to decline. Atlantic croaker, which is more of a mid-Atlantic fish species, is going to be moving into New England and doing quite well. Lobster, right now the data is relatively ambiguous. We don't know, though I'll show some data later on that suggests that at least in southern New England, the lobster fishery is heavily impacted by climate change down the west. So making predictions, we're pretty good at saying that the fish species might be moving northward. We're still trying to understand how other factors associated with climate change might affect population size. One of those other factors is disease. There are a large number of disease vectors that live in the ocean that affect both marine organisms and potentially human health. Many of these vectors, bacteria, protozoans, fungi, do better under warm temperatures. Either their growth rates are faster under warm temperatures, they're not killed off because of a cold winter. And what we're seeing is a northward expansion of those disease vectors over time associated with this warming. So this is, for example, dermo. It's a disease that affects oyster. It used to inhabit primarily the Gulf of Mexico and the Mid-Atlantic and Southeast. And what you see here is it was primarily found down around Chesapeake Bay prior to the 1950s, 1960s. And over time, we've seen mortality events spreading through the 80s, 1990s, and up to the present as it's moved northward up into New England and into the Gulf of Maine. This is a common feature for a number of different disease vectors that we're seeing in northward expansion into our region of diseases that didn't used to be a problem. Temperature and climate change also affects invasive diseases and invasive species and exacerbates those problems as well. So that's temperature. What are some of the other effects? Well, I mentioned before that a warmer ocean evaporates more water. We'd expect to get more rainfall. And in a rather perverse way, we expect to get more rainfall in places that are already relatively wet, and we expect to see less rainfall, drier conditions, in places that are relatively dry. So for example, the US Southwest, and particularly down into Mexico, are relatively dry regions. They will probably get drier in the future, where regions that are relatively wet, such as New England, will likely get wetter. And these are observations showing that the amount of precipitation in New England is actually going up with time. In addition to the average amount of rainfall, we're also seeing more intense rain events. So the strongest precipitation events are occurring more frequently, and that's leading to more flooding, particularly in the Midwest and the Northeast. And this can have impacts on coastal wetlands and coastal water quality as you're leading to more erosion, more runoff of different materials into coastal waters. One of the other topics that's associated with rising levels of atmospheric carbon dioxide isn't necessarily climate change. It's simply the fact that a substantial component of that carbon dioxide, about a quarter of all the carbon dioxide we emit to the atmosphere, gets dissolved into the ocean. And when it gets into the water, it forms carbonic acid, and it makes the water more acidic. So in red is shown this atmospheric CO2 curve. As that's been going up with time, the amount of carbon dioxide in the ocean has been going up as well, and the acidity of the water has been increasing as well. And there have been a number of studies showing that more acidic waters are bad for many types of marine species, particularly those that make shells out of calcium carbonate. So things like mini shellfish and corals, calcareous algae. And this is just shown here, a panel. This is low CO2. These are sort of ambient conditions of what we're seeing right now, and these are going to higher and higher carbon dioxide levels. And what you see is, this is for a particular clam species, the clam tends to grow more slowly under more acidic conditions. The shell is thinner, and mortality is higher. And this has been shown for a wide variety of shellfish. And so we're trying to understand not just climate change, but also the effect of carbon dioxide and ocean acidification. I should mention that yesterday there was a lot of discussion about nutrient pollution and water quality. The nutrient pollution also leads to local acidification. So we're already seeing in many of our bays and estuaries more acidic conditions that are just exacerbated by fossil fuel emissions as well. So finally, I want to wrap up with sea level rise. I mentioned at the beginning that under climate change, we see warming of the ocean. That warm water expands, and so sea level rises. We're also seeing melting of glaciers and ice sheets on land. That extra water gets into the ocean and leads to sea level rise. Over the last 200 years, we've seen roughly a little under a foot in sea level rise. This is going back, the blue is tide gauge data, the green is satellite data. They overlap and complement each other quite well. We have proxy records going back several thousand years for sea level rise. So about a foot so far, but sea level rise is increasing, it's accelerating. This range in gray here, the 1 foot is the estimate if we just look at the effects of warming ocean water. The 4 feet by the end of the century is if we include melting of sea ice, or excuse me, melting of ice sheets in the Antarctic and Greenland. And I don't know if you saw the news a couple weeks ago, there's increasing evidence of melt of both Antarctic, the West Antarctic Peninsula, and ice sheet, as well as Greenland. And I think there's growing evidence that we're probably not going to be at the 1 foot level. We're probably going to be somewhere in the middle or the upper part of this range. Now, sea level rise by itself will lead to inundation of many coastal areas, but it also exacerbates coastal storms. It makes coastal storm surge worse. There's also the possibility under climate change that the intensity of some of the storms will get worse because of warmer ocean waters that power these storms, more water vapor in the atmosphere. One way of thinking about the effect of sea level rise is to think about the return frequency of really intense storms and storm surge events. So we often talk about a 100-year storm, a storm that you would expect only to reoccur on average once every 100 years. Well, with sea level rise, you take what was a 100-year storm and you decrease, you make them more frequent. So what used to be a 100-year storm now might be occurring every 20 years, every 10 years, every 30 years. And so that exposes a larger population to more intense storms, and it also expands the boundary of where you would expect coastal inundation and flooding. Now, sea level rise is going to impact a whole variety of benefits that we get from the ocean. So for example, food resources associated with aquaculture, coastal fisheries, coastal protection from storm surge and inundation, tourism and recreation. As we're moving sea level rise, we can damage coastal infrastructure associated with tourism and recreation. And there's a variety of different proposed actions to deal with sea level rise. Probably the simplest I'm just showing here is trying to armor the coast. Basically put up hard barriers that try to protect coastal resources from sea level rise and increasing storm surge events. Another is coastal habitat restoration, shown here where you might, for example, try to replant wetlands, restore wetlands that can act as a buffer for storm surge events and sea level rise. There's a lot of interplay, and I know this is the topic for much of this conference and today, but there are both positive and negative interactions between, for example, coastal armoring. Coastal armoring might lead to better coastal protection, but it can have big negative impacts on the health of wetlands and the health of ecosystems that might lead to declines in food security. So when we're considering resilience strategies and adaptation measures with respect to climate change, we really need to look at not only the direct impacts of the adaptation strategy, but how that filters through all the other services that we depend upon from the ocean. So I started off by saying that I was an author on the National Climate Assessment. These are produced roughly every 4 to 5 years. We just completed the 3rd of these climate assessments. All the information in the climate assessment is available online. If you just search for National Climate Assessment, you should be able to find it quite easily. There are PDFs of the entire report, but it's also a nice web page that you can search. It's broken out by overall climate effects, but also regional effects of different geographic regions, coasts, oceans, but also different sectors of the economy. So for example, transportation, energy, let's see what else, water. So there's a lot of different crosscuts within this report, and I highly recommend if you're interested to take a look, and all of this is available free online. So thank you, I'll stop there and I'll take questions.